Welcome to Zaption Tour 5.7, Scatter Plots and Trend Lines. Here is the essential understanding that we're going to be covering. You can determine whether two sets of numerical data are related by graphing them as ordered pairs. So we have to make sure that we remember how to graph as ordered pairs. And if the two sets of data are related, you may be able to use a line to estimate or predict values. A lot of this lesson we're going to do in class together with a calculator demo, so this is just the basics, but let's get started right away. Box number 1 is the idea of what scatter plots are. The definition that we're going to use and stick to is a graph that relates two different sets of data. And there are three main types. So take a look at graph number 1 here. I am relating x with y, and the scatter plot is the ordered pairs sets of data. And in this particular case, you can kind of see that the data sort of goes up and to the right. So as x increases, y tends to increase. This is called positive correlation. Positive correlation. Number 2, again, the same kind of graph. I'm relating x to y. But in this particular case, as x increases, our y values decrease. You could probably guess this is called negative correlation. And then in number 3, I'm relating x to y, and there's really no line that I could really draw to represent this correlation, so we would say that there is no correlation in this one. So again, the first one is positive correlation, the second one is negative correlation, and the third one, there is no correlation whatsoever on the scatter plot itself. So in box number 2, this is an example of how that we would make a scatter plot and then describe the correlation. So the two sets of data is altitude versus temperature. And I used Desmos to help me graph this. And we're going to be using our calculators and Desmos as well, but I just wanted to show you what the graph looks like. So if I took the graph, and it looks like this, okay? So you can see as my altitude increases, the temperature kind of decreases. So if we had to make a guess, well, we would say that this graph or this data is negatively correlated. So this would be an example of number 2 up here in this one, like we did in box number 2. So we made the scatter plot using some technology. We're going to do that in class, but this is basically a negative correlation. I just wanted you to see one. Box number 3 is the difference between these two words, interpolation and extrapolation, and writing the equation of a trend line. So the definition for interpolation, this one here, is below. That's when you are estimating a value between two known values of your data set. And extrapolation is predicting a value outside the range of your known values. So there's the difference between these two words. So interpolation, this definition is here, and extrapolation, this definition is here. And I want to do this example with you right here. We're going to compare two sets of data. We're going to compare age to weight. So I've drawn, or I've used Desmos to actually make a scatter plot. And if we were going to make or describe the data, we would say that this is generally positively correlated. And the next thing I want to do is show you how to get the equation of a trend line out of this. So let's go ahead and do that part next. So this graph is an example of a positive correlation scatter plot. And what we want to do is we want to get a trend line. Now I'm going to show you how to do this in the calculator later, but for the purposes of this lesson, I want to show you where this is coming from. The first thing I want to do is pick 2 points that are the data that is actually on the graph that I can use. I'm just going to pick 4 and I'm going to pick 8. So I'm going to pick basically this point here and this point here. And what I'm going to do is I'm going to create the equation of a line given those 2 points. So the first thing that I want to do is I want to get the slope. All right. So the slope is going to be, of course, y2 minus y1 over x2 minus x1. This should look really familiar to you. So that's going to be 37.9 because I'm using this point here, minus 17.1 because I'm using that point there, all divided by 8 minus 4. 8 minus 4. So when you calculate all this, you get the slope to be approximately 5.2. So that's the first thing I want to do. Okay, the second thing that I want to do is I want to write it in point slope form, so I can use someone to have y minus y1 equals m times x minus x1. So I'm going to go ahead and use this point here to plug in and figure out the equation of my line. So I'm going to have this. I'm going to have y minus 17.1 is equal to the slope that I have been given, or that I figured out, which was 5.2 times x minus 4. And then what I would do is I would distribute, and I would move my graph down a little bit here. So I'd get y minus 17.1 is equal to 5.2x, and then this value is minus 20.8. Okay, and then I would add 17.1 to both sides, and I would end up with the equation y is equal to 5.2x, and then minus 3.7. So I want to show you what this looks like, okay? If I go over to Desmos real quick, because I already have it up on the screen, okay? So here's the scatter plot of what we created, and then the equation of the line that we just figured out together was 5.2x minus 3.7. So when I graph this line, this is what's known as a trend line. So it's a line that goes through our data that is a pretty good fit to our data. And that's what it means to find a trend line of the data and how we did it. The fourth and final box for this particular section is something called the correlation coefficient. And the definition that we want to use and understand is this. It's a number, and it's given by the calculator, and I'm going to show you how to do that in class tomorrow. That's between -1 and 1. That tells you how close your equation models the data. So basically, it tells us, when we look back at this, it tells us how good of a fit is that line. How good of a fit is that line? So it's the traditional variable that they use is this variable r, and it counts for the correlation coefficient. And here's the deal: it's between -1 and 1. So I'll put a little scale on here to teach the idea. Okay. If your r value is closer to -1, that means that you have a strong negative correlation. Strong negative correlation. So that means it's not associated all that much. If your value of r is closer to 1, then you have a strong positive correlation. So the graph's a strong positive correlation. If your r value is close to 0, then you have no correlation whatsoever. Your line is not correlated to your data. So we're going to be doing some of this and understanding it and looking at some graphs in class tomorrow. But I wanted you to understand what the correlation coefficient is. And this is basically what it is. It's a number between -1 and 1 that tells you how close your equation models the data.